Hello, this is the patch I'll be presenting in this video for my music processing project. First of all, I'd like to excuse the poor audio quality of this screen recording video. I tried to improve it. I'm not working in my regular computer, so I did what I could. I hope everything is clear, more or less. And so, my patch is based on a Monome sequencer, which is a piece of hardware made in the United States, which has become pretty popular lately. And yeah, the name Monome it's also become a common place for any similar device that is mimicking the design and functioning of the original device. So here you can see the looks of the Monome and the simplicity of the design, and here you can see how it works. And yeah, the device needs a software to function properly, and it uses the Open Sound Control Protocol, the OSC protocol, to communicate with the computer. And the function of each button depends on the software, so it can become pretty complex depending on the underlying software which is controlling it. Okay, this patch here will take sounds and we play them, and will allow the user to manipulate the pitch and the speed. Okay, let's see an example. We're gonna use a bell sound sample. Okay, so there are 18 tracks and each track contains 10 samples. So we're playing around with the sliders. The right slider is for the pitch and the left one for the speed. Okay, in this case we are using environmental sounds from the Vascula that I recorded myself in September. So these are sounds produced by heating sculptures, not Dylan, and dropping rocks in the lake, and so on. So we can actually change the look of the panel by selecting an appropriate image that contains the on and off states. Okay, so we could try recording on the fly. Mooi. 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 Mooi.
Mooi. Mooi. Mooi. Mooi. Mooi. Mooi. Mooi. Mooi.
Mooi. Mooi. Mooi. Mooi. Mooi. Mooi. Mooi. Mooi. Mooi. Mooi. Mooi. Okay, what I'm gonna do now is I'm gonna try to explain how the patch works inside. And so we move in, and first of all we have this metro object here, which sets the tempo, the speed at which the lights move from one node to the other in the panel in this matrix. Yeah. Then, okay, by default it's 200 milliseconds, but we can tweak this here. Then the sliders here control the maximum at which the lights go in the panel. For example, if I set 2 here in the 17th column, the light will go to the 3rd row. This patch has 2 inlets. One is coming from the metro object, which gives information to the counter object about the tempo at which it counts, and this second inlet comes directly from the respective slider, which sets the maximum at which it counts, as we can see here in this integer box. And so, okay, to simplify, because I'm not gonna explain every little detail, at the end we have 2 outputs from this bucket object, which what it does is send the value it stores with 1 step delay. So to visualize what I want to explain, yeah, actually it could be 2 because we only need 2 outlets. So you can see here that information is sent 1 in delay. And why is it doing that? Because this value here, 1 and 0, means state on and state off. So for the on state, we get this image, which is the trigger, the lit image, and the on state and the off state goes behind. Because if we didn't have this outlet here, we would be leaving the trace of the on object. So one off state needs to lag 1 step behind, so we get the effect of lights moving up and down. Jesus. Okay, I hope it's clear. Yeah, I can delete this. Okay, next thing is the matrix, which is sending information through this outlet to this object about what's going on in the matrix. There are three types of information: information about the column, about the rows, and about the state on or off, represented by lit cells. And so the unpack objects obviously unpacks those 3 elements and sends them to these conditional statements. There are 18 conditional statements for each row. And so, for example, this one says if column 0, which is this column, and row 7, this is the row 7 because it actually the matrix counts top down, and state 1 is a state on, so the lit cell. Then bang, okay, it will send a bang whenever, like now, whenever it reaches the 7th row. Whenever the on state reaches the 7th row, it will send a bang. Okay, and this bang is exactly what triggers the sound. Okay, I think the most complex is already explained, which is not that complex. The previously selected audio file will be triggered whenever it reaches that. Okay, to change the pitch and the speed, we use this subpatcher here. And so this is the speed part. Right, we can change here the speed. It's only this area here. Of course, it changes the pitch as well. I couldn't find a way to unite these two things while keeping the independent pitch modification at the same time. But probably I'll try to figure out some other time. And so the pitch part is here. It's using what we have. That is the sound coming in. These two outlets are just because of the left and right, because of the stereo sound. I'm gonna turn this. So by means of fast Fourier transform and inverse fast Fourier transform, we do the spectral processing here in between, F in, F out, FFT inverse FFT, and this gizmo object is what does the pitch change in the frequency domain. Okay, this part here is okay. Sounds good. Okay, actually, this button here resets everything to its normal state, which is one speed and one pitch. Okay, this part here scales the tones coming from the keyboard here. Here, this keyboard here. Actually, this one is the last one. You can see how the value changes. So it scales the semitones, which go by integers, to the appropriate value for the gizmo object. Good. And that's basically everything. So you can change pitch and speed for each one, and by pressing here you can reset to the element. Yeah, that's pretty much everything. As I mentioned earlier, you can, this is nice, you can change the color of the panel. This is much nicer, I think it's better. And that's everything. Thank you very much for listening, and sorry about the audio quality.